Okay, so welcome back to part 2 of section 1.2. We're taking a look at graphing linear equations now. So in the earlier part, we found the linear equations, and now we're going to take those and turn them into graphs. Graphing lines can be broken down into two basic categories. Given a graph, find the equation from that graph, and given an equation, sketch the graph of that equation. We've already done the first one. We've already said, hey, here you go, find the equation. Now let's take a look at sketching the graphs. Most commonly, we use the slope-intercept form of the equation of a line when we're going to do our graphing. The reason being is when it's written in slope-intercept form, we have the slope m and the y-intercept b. They're written there, right there for us, so they make it easy. For example, down here, if I take a look at this first one on the left over here, my job is to sketch the graph of each of the following, and this one in this case is y equals 2x plus 1. Since the equation is already in slope-intercept form for me, I can just read right off of it and know that my slope is 2 and that my b is 1. That means that my y-intercept is the point 0, 1. So I can come over here to my graph and I can put a scale on it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and just make some quick points over here, and we'll sketch it. I know that my y-intercept is 0, 1, so I know it's going to cross the y-axis there. I know that I have a slope of 2, which means that if I go over 1, I go up 2. If I go over another 1, I'll go up another 2, and then I can make my graph from there. I could have also graphed by going left 1 and then down 2, because if going right means you go up 2, then going left would mean you go down 2. And any way I do this, there is a quick and dirty sketch of my line. Now, if I wanted a more accurate graph, I would spend time to make that more accurate graph. Maybe I get out a ruler and measure those tick marks appropriately, or use some sort of a graphing technology. Okay. So there's basic graphing, slope-intercept form. What do you do when the line is not in slope-intercept form, like this one? Here we have a line that is given to us in more of a general form. But it's not even general form, because general form is x and then y and then equals that number. But what do we do? Well, we have options. We could either leave it as it is and try to make it work, or we could take it and put it into slope-intercept form. Now, personally, I would do that, which means I would take these two guys and move them to the right-hand side, which would give me 3y is equal to negative x plus 6. I'd divide through by 3, and I would get that y is equal to negative 1/3 x plus 2. And now I've got my slope. I've got my y-intercept, and I can go from there. So I'll put some tick marks over here. Let's see, 1, 2, 3, 4, 5, 1. You know what? I'm going to go bigger. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then I'm going to plot my y-intercept at 0, 2, and then my slope says negative 1/3. Now, negative 1/3 technically means when x goes up by 1, y goes down by 1/3. But that's kind of hard to grasp, so I'm going to reinterpret that to mean when x goes up by 3, 1, 2, 3, y goes down by 1. And then if x were to go up by 3 again, it would go down another 1, and I can sketch that line in and find that. So there's a sketch of my line. Right? So, as a summary, we have general form. Now, this author of this textbook says general form is that. I have also seen other authors say that this is general form. Whether you put the constant on the left-hand side of the equal sign or the constant on the right-hand side, I've seen it done both ways, so I don't really know which one's correct. But I would accept either for general form. We have equations for vertical lines, and we have equations for horizontal lines. Remember, vertical lines and horizontal lines only have one variable in their equation. It's either x equals or y equals. We have the slope-intercept form, And we have this last one down here, the point slope form. I cannot tell you how many times this semester you will be using that, because we will be finding equations of lines again and again and again and again and again. In fact, if there was one problem that will most likely be on just about every exam this semester, it'll be find the equation of a line. It might not be the entire problem, it might be just a step or part of the problem, but it will be involved in a problem on probably 80% of the exams this semester. It's just something that happens in calculus all the time. All right, so let's take a look at a couple of special cases. Parallel and perpendicular lines. Now, there are geometric definitions and then there are algebraic definitions for parallel and perpendicular lines. Okay. Here I have an example of two parallel lines with slopes 1 and slopes m sub 1 and m sub 2. And geometrically, the definition of parallel means they don't intersect. Algebraically, the definition of parallel means that the slopes are exactly the same. Right? Now, this picture happens to have both lines drawn having positive slopes. That's not to say they couldn't have negative slopes and still be parallel. Over here, perpendicular. Geometry says perpendicular means they intersect at a right angle, right? 90 degrees, or what is that, pi over 2 in radians? Because calculus loves radians. That's the geometry. Algebra says the two lines are perpendicular if their slopes are opposite reciprocals. Now, that formula happens to be written as m sub 1 is equal to that, but you could just as easily say that m sub 2 is equal to negative 1 over m sub 1. With a little bit of arithmetic, with a little bit of algebraic manipulation, you could turn one of those statements into the other. Okay, so two lines are parallel. Definition of parallel lines algebraically is the slope of the first line is equal to the slope of the second line. Definition of perpendicular algebraically is slope of the first line is equal to the negative reciprocal of the slope of the second line. Now, one thing the students sometimes ask in these definitions, what's the dot there about? That is called a period. It is a punctuation mark, and it denotes the end of a sentence. So this is a complete sentence right here, and that's a period, punctuation mark. Okay? Here we got another sentence, period, punctuation mark. I know it seems awkward to have it there. Grammatically, it's correct. Just visually, it seems iffy or wrong. Okay? It took me a little while to get comfortable with it. I think that I'm comfortable enough with it. Okay? All right, so what do the directions say here? Find the general form of the equations of lines that pass through the point 2, negative 1, and are parallel and perpendicular. Ooh, so we're going to find equations that are parallel and find the equations that are perpendicular. Okay, we can make this happen. All right. In order to find two lines or a line that is parallel to this, I need to know what the slope of it is, because parallel lines m sub 1 must be equal to m sub 2. So how am I going to find the slope of that line? Well, the easiest way is just to algebraically manipulate it and put it into slope-intercept form. That way I can just read the slope off of it. And so now I know that my slope is 2/3. I'm just going to call that m sub 1, which I know that m sub 1 is the same as m sub 2, so it's all good. Okay. And now what I'll do is I'll take this point and that slope, and I'll make a line. So y minus a negative 1. Oops, I forgot my own rule. I need to write down the formula I'm using. I'm using the formula for the point slope. Got so excited because this is awesome that I stepped ahead of myself there. Let's see. And how do you feel about that as a solution? Okay? Because I would tell you it's wrong. Here's what's wrong with it. What did the directions say? And what did I do? So that's the slope-intercept, and they want the general form. Remember, general form, general form, general form, general. Oh, general form is this guy. AX plus BY plus C is equal to 0. So this isn't right. This is slope-intercept. So what I need to do is I need to take this and move it back over to the left, which would give me what? Negative 2/3 x plus y is equal to negative 7/3. Now, some people will argue that then you should multiply through by 3 and make that be negative 2x plus 3y is equal to negative 7. Other people will then argue that you should multiply through by a negative 1 and get 2x minus 3y is equal to 7. That's an ugly y. Now, any one of those is technically correct. Do you see why people would like the last one, the purple one, the best, though? It removes the fractions and it makes that leading term positive, which is nice. Those are nice things. Fractions cause people trouble. Like, for example, in that first one, as it's written up there in brown, is that 2 over 3x or is that 2/3 times x? I don't have that issue in either the light blue or the purple. Right? And negatives sometimes get lost. I don't have that issue in the purple. So I would make the argument that for clarity, this is the best one. Not to say the other ones are wrong, it's just the best one. Now, some of you may have noticed that we could have shortcut this, because if you look at the last one, you look at the original equation, if the lines are parallel, the coefficients of the x and the y are the same. The only thing that changes is the y-intercept. Because when two lines are parallel, the slope is the same. The only thing that is different is where that line crosses that y-axis. So what we could have done, if we knew that and we wanted to go faster, we could have taken the original equation, which was 2x minus 3y was equal to, I believe, 5, and just solved for the new y-intercept by using the point on the line to negative 1 up there. Oops, I didn't want to scribble that out. So I could have gone 2 minus 3, 4 plus 3, 7, and just replace that with a 7, I would have been done. Not everybody knows that. Not everybody sees that. But if you do see that, that's much faster. All right, perpendicular. Well, I already know the slope of the line because I found it already. I know my slope is 2/3. So what's going to be the slope of the perpendicular line? Well, it's going to be negative 1 over the original slope, or it's going to be the negative reciprocal. So what's that? Negative 3/2. So then, now, I kind of do have to use the whole point slope and all that business to make this work. So let's see. Y minus negative 1 is equal to negative 3/2 times x minus 2. So y plus 1, negative 3/2 x plus 3. And now, since I know what I'm supposed to do, general form, I'm going to move both of these terms over to the left, and that's going to give me 3/2 x plus y minus 2 is equal to 0. Again, I'm going to multiply through by 2 just to clear it out. That gives me 3x plus 2y minus 4 is equal to 0. And I think that looks best. I'm not saying that this one is more correct than this one. I'm just saying, to my eye, I prefer the last one. I hope that you would too. All right, so that brings us to the end of section 1.2. At this point in time, you should be able to finish up the homework in WebAssign for section 1.1. You should be able to finish the homework in WebAssign for section 1.2. Have a great day, and I'll see you back here for 1.3.